Okay, so our next application of electromagnetism is going to be the electric motor and then the electric generator. So before I talk about it, I need for you to watch this little video here, wire in a magnetic field on YouTube. Okay, so watch that video. Are you done? Okay, so what did you see? So what you should have saw was there was a magnetic field that looked kind of like this. And so there was a magnetic field in between the two poles of the magnet. And then there was a wire like this that was hanging in between the two poles of the magnet. And then they turned on electricity. So as long as there was no electrical current in this wire, you noticed it did not move. But once they turned on the electric current, then depending on the direction of the current in the wire, it either came out of the magnet or it moved into the magnet. So what I want to do is to explain that, but I need to take my magnet and I need to turn it sideways. So that's what this picture is going to be. Okay, so I'm going to have the north end of a magnet, and then I'm going to have the south end of a magnet. Now you might be wondering, how is that possible? What we can do is take a bar magnet and we can bend it into a U-shaped thing. So that's going to be a U-shaped magnet, and it's going to look something like this. So my artistic abilities are limited. But anyway, you can see how you could take a straight magnet and then you can bend it into a U shape. So that's not important. The important thing is that it has a north pole and it's got a south pole. All right, then if you were to take a teeny tiny north pole and put it in between the poles of the magnet, what direction would it go? It would be repelled by the north and attracted to the south, so that in here you would have a magnetic field. So here's the magnetic field B in between the poles of the magnet. All right, now we need a wire. So I'm going to illustrate that with another pen, and this wire is going to be into this magnet like this. So it's going to be going in and out of the board, but in order to show it to you in 3 dimensions, I'm just going to make a line that looks like this. So this is going to be carrying a current I, and it's going to be going into the board. Now, what I'd like for you to do is to use your right hand rule to predict what direction would that wire want to go. So let's review. Here's your 3 fingers. Okay, the thumb is the direction of the magnetic force. Okay, then this is the direction of the current, I, and then this one is going to be the direction of the magnetic field. All right, so use your right hand rule to figure out the direction that current carrying wire would want to go. Okay, got it? Okay, so that this is the direction of the current. It's into the board. Okay, this one is the direction of the B, which is going across. So I need to rotate my hand so that this finger here is pointing in that direction. My current is going that way. Look at the direction of my thumb. So my thumb is pointing down, so the direction of the force is going to be down. So this is the magnetic force, and it's going to be pulled down. So this wire that used to be like this is going to want to do that. It's going to go down. Okay, now let's take our wire and bend it. So I'm going to take this wire and bend it like this, and now it's going to be coming out of the board. So here's my, sorry about the noise, it's going to be coming out of the board. So now it's coming this way. What would be the force on this wire? Okay, do the same thing, right hand rule, but this time we're going to find that this wire is going to want to go up. So it's going to want, so this wire is going to want to be pulled down, but the wire that's on top of it is going to want to go up. Okay, now we could do one more thing, and we could connect these two right here. So now it's making a loop. So now you've got a loop of wire. You're going to turn on the electricity, and now we want to know what the loop is going to do. So let's say that this wire over here is this one. And let's say that this wire over here is going to be that one. What's it going to want to do? Well, this one's going to want to go down, and then this one's going to want to go up, so it's going to twist. So the loop of wire is going to twist in the magnetic field like this. Well, that's not much of a generator, or it's not much of a motor, because all it's going to do is it's going to flip like that. Okay, so what we want to do is to have some mechanism that as soon as it's rotated up to this position, the current reverses. Because if the current reverses, this one wanted to go up, but if the current reverses, now this one's going to want to go down. And this one that went down is now going to want to go up. And so again, it's going to continue to rotate. So if we have some kind of a device that changes the current in the loop, it's going to continue to spin. And so that device is going to be called a commutator. And so if you want to watch the video, there's another video that says commutation there that you can watch, and it explains how a commutator works. You don't need to know that for the exam, just that a commutator changes the direction of the current. So now what have we just done? So we have that current is going into this machine. So here's the machine, whatever it is, and then what's coming out of the machine is motion. It's causing something to rotate. That's an electric motor. So an electric motor takes electric current and turns it into motion. A fan. So an electric fan would be an example of an electric motor. Okay, now, again, we're going to use the magnet. We're going to use the coil of wire, but this time no electricity. So there's no electrical current in the wire. It's just sitting in the magnetic field, and we're going to attach a handle to it. So we're going to put a handle on that coil there so that we can manually turn it. So we're going to turn the coil in the magnetic field. What do you think is going to happen? It's going to generate electricity. So when we do that, this time we're going to have motion, and that's going to go into the machine, and then what's going to come out is going to be electric current. So this thing up here is a motor, but this thing down here is going to be a generator. An electrical generator, you put in the motion part, and then it generates the electricity. The motor, you put in the electricity, and it generates the motion. But it's the same machine. So that a motor is a generator running backwards. And a generator is going to be a motor running backwards. And so these generators and motors are very, very important in today's society. So on the exam, can you make this picture? Can you make a picture of a magnetic field, a wire in the magnetic field, and then explain the direction that the wire is going to want to go using your right hand rule? So that's something I would expect you to be able to do. Okay, we're also going to do another application of electromagnetism called the transformer, and we'll do that in our next segment.